Hello everyone, this is the third video, and in this video I will explain how to do optimal design optimal optimal design of any project that you have. Previously I explained how to do uh, online optimization as you see in this project, but this is not suitable for optimal design. So this is suitable, the online optimization, after designing your project. Now I will show how to do this design, and you will see how the process of making this offline optimization or design optimization, which is different. And I hope that you uh, uh, bring your attention to this video to know how to do this offline or design optimization. And let's start. First of all, I will create now a new project for Grey-Wolf Optimizer. I will call it Grey-Wolf, for example, Grey-Wolf Optimizer. Then, okay, now this is Grey-Wolf Optimizer. This is a new project. This Grey-Wolf, I'm going now to, I have this one that we designed previously. So I'm going to copy this one to the Grey-Wolf. So you can see now, this is the Grey-Wolf in the new project, but you need to check this link to the other project, which is Grey-Wolf 2. So here we have this problem, how to do this, because if you close the other one, this will not work. So you should go there in the project, go to the definitions, and Grey-Wolf. Here you will find this Grey-Wolf. You need to copy this one, copy with dependents, and go to the new project, and at definitions make paste definitions. So now you will find your Grey-Wolf here in the new one, and for your Grey-Wolf you now link it to the new one that you created. So now this is linked to the existing project. Okay, so now I will save this one. This is the Grey-Wolf. And for offline, you need to also define new project. This, you can call it, for example, my project, and this is separate file. Now the optimizer will be in separate file from the objective function, and I will go there, for example here, and I will copy our previous I don't need this one. For example, I will copy this one. Here you will find this is different. So our project, our function here, which is sphere function. Okay, and this one also, the constant, we need constant. So same, I will make this one, for example, 30, 50, anything. Okay, and I can measure also the reference value as we did previously in the previous video. So this is reference value. Now, how to link both? This is the problem. How to link Grey-Wolf with this project. So what we need to do, we need to go to the master. We have master library. Then we have this import export, and we have this wireless. You can see those wireless, transmit and receiver. So this is the transmitter. I will copy this one and go here, and I'm going to transmit this X variable, and I will name it, for example, X variable, okay, or xv, no problem, okay. And the dimension, as we know that, for example, we used previously 10, so we can use now 10, and this is transmitter. And as we know this temporary, we can now copy this one, or we can use from component here, see? And this is now receiver. I will make it transmitter. And here, this is the storage. I can name it, for example, store 1. And we know that the dimension is 44, as we explained previously. As we know here, this is the dimension is 44 for the storage, and this is 10 for the variable. So I'm going to connect this one. And here also for this input, what we need for objective, we need here receiver. So I will use this one as receiver, okay. And for example, this name, for example, objective value, and we know the dimension is 1 for this objective value, okay. Same, I will use receiver for the storage that I send. I will make it, for example, store 2. And you should be careful about the variables naming. If there is capital, if there is small, you should consider it. And here is 44. So previously only we used, you can see we used only this loop because this is inside the project. But now no, I cannot use this one. It will not, because here I'm using I'm going to use multi-run. And how to do this multi-run, I will show you. Now this is Grey Wolf, and okay, objective, I will receive from where? This objective, I will receive from my project here. This one, for example, I will make this one. I will use transmit, and this is, for example, the objective. I should be careful. If it is capital, it should be capital. If it is small, it should be small. For example, here I'm using capital, so I should use capital here, objective. And this objective, this is that I will transmit, okay. So now this is the first one. X variable here, it should be receiver, so I will use this one as a receiver, and this is the variable, X variable. And there, what I named this one as XV, so this is XV, and the dimension is 10. For this storage, what I need to do, I should, for example, make radio link, and this is receiver. What I will receive here, I will receive store 1 with 44 variables, and then I will transmit it. I will transmit this one, store 1. Here I will use transmit, and then store 2. So I used this method just for storage from first iteration to the second iteration. So this is the trick. Now for objective for these receivers, you can see now there is 2 brackets, open brackets. That means here I should define from where I'm receiving, from where. So I'm receiving from the other project, which is here. You can see my project main. So I should be careful about the letters. My project main. So now I can copy this one and paste here. So receiver, I have these brackets, but for transmitter I don't have, so I don't need to use any any name. Same here for XV. This is I'm receiving from where? From Grey Wolf main. So I should be careful also. Grey Wolf main, and I will copy this one. I will use it here too. Okay, so this is now our two projects. I will save this one, save this one. Previously I was using this one to start. You can see here I will copy this one to, but here this is not time dependent, this is multi-run. So for project, you can see I am going to project here, and I will change this one from none. I should make now, I have master and slave. Master, I will make Grey Wolf as a master project, and this is number of runs. If I want 100,000 to, so maybe I will make it, for example, 100 here. Okay, and the other project, my project, should be the slave. Same, this is here, you don't, it is not important if it is 10, 100, no problem. So now I have this one. So instead of time, using time and this delta, I will use different thing, which is run, number of run. This one is related to the multi-run. So now I'm this is current run number. I will compare it, for example, with 2. So I am going to add, for example, integer or real, no problem here, and I will give it 2 runs to, for example, make initialization. This is for initialization of the Grey Wolf optimization. So we have now 10. We have now total numbers. For example, I need 100, as this is now multi-run. So I should use this 100, the same of multi-run here in the project. So be careful. Now, what I need to, for example, observe the objective value. So I can add as overlay graph here. So now by this one, I can observe the objective value during the optimization. Now, this one is done. If you want to, for example, monitor the storage here, what I can do, I will make by component, I will make here tab, and this tab, as we know previously that the best one is 41. So now I'm going to, how also I need to monitor the best one, but as we know here multi-run. So to store the values, I need to use also the transmitter, but I don't need, now this is transmitter, and I will call it here, for example, best. Okay, and what is the, this is now single value, so no problem, dimension is 1, and I'm going to add as a curve here to show the convergence of the best one. If I want to see, for example, the best solution, for example, I can use this one here, and from this channel I'm going to, for example, I would say this is X optimal. I want only to see the X optimal and start at index. For example, we know that it is starting from 11 to now, no, this is dimension, so 10, so from 11 to 20, you can see this is the X optimal. And how to I will add as a polymeter here, you can see, and here you will see the 10 variables, the changing of the 10 variables. Now I will save this one. You need to save every steps, otherwise if there is any interruption you will need to do it again. Now in here this is the okay, everything is okay here, so I will save also this one. Okay, now we should make sure that all dimensions are okay. After that I will go to the Grey Wolf optimizer Now everything seems okay. So as we said, Grey Wolf is a master. This is now for us is offline. For us, this one is offline optimization. Okay, so this is offline optimization, or also we can call it instead of offline, we can call it, for example, this is design or optimal design. We can call it this is optimal design. Okay, so now to do this one, I have now two projects. If you run this project, it will not work. It will not work smoothly. So this one, it will not work smoothly. So for example, if you go to make a run, I will save this tutorial also. Okay. If you want to go to do run, you will get error. This error, that means it cannot receive those values. So how to do this one? See, you will go to the simulations, be careful here, the simulations, and add new simulation, make it new, and you can name it anything. You can say, for example, optimal design. So for example, this one. Now we added optimal design as a simulation. Now in this simulation, you will say that include which tasks, include Grey Wolf and include also my project. So here in this simulation, you will run both because there is wireless transmit and receive. Okay. Now, if you want to run this, you will not go to run here. No, you will right click here and run as a set. So you will run this set like this. Okay. So there is unsuccessful. Let's see where is the problem here. Okay. There is storage. Okay. This is, we didn't change it. 44 and this one 44. Okay. This one 10. So okay, now it is okay. I will save this one. I'll go back and run set. So you will find this trouble usually, that your system will crash. So we didn't save this one previously. So optimal design. Okay. And for this optimal design, I'm going to include, as we said, Grey Wolf and my project. Okay, I will save now. I will save this tutorial. So this will be saved for the other one. Okay, now everything is okay. I will go now again and see run set. Now it is working. You can see this is working, and you will find it is now changing. Okay. So we can see that this is taking much time because we don't need this duration of run. So I can stop the simulation and go back, and I don't need all these things. I will make it, and here maybe I'll make it 50, no problem. Save, and for the other one also make it 0.05 and 50 because we don't need this time to make it now faster. And again, I will go back to the run set. I will make this one as bold. This one also, I will make it as bold. And you can see now the iterations 40, this iteration is changing. Until we reach 100. You can see how this is changing. I can make now, for example, instead of starting from 1000, I can make it start from 100 because that is the best. And the grade can be, for example, 10 or 20 or anything. You will see now how the optimization run. And this one also, if I'm using from 0 as we used in the upper and lower limit. So you can see how this is changing. See, from 0 to 5. This is the optimal design of these variables. Each one is different. Once you click, you'll find different values. And here you can see it is 0.12. It should be 0, the best one, but it's reaching 0.127. It is okay now. This is the powerful of the gray wolf. And if I want to increase the number of iterations, I can, for example, say here 200. But also I need to make sure that also for the master, then the number of runs is 200. So again, I will go here. Don't run this one. You will go to the optimal design and run the set. And again, the optimization will start again to find the best solution. As I said, this is for the optimal design. Here, what is happening now? This project will be run 1000 times. Each time it will try any variable, X variable, and then it will try another variable, and so on. So this is the point that is happening here. So this project is running. So if you want to plot this objective, you will plot for each run only. It will not be recorded, this objective. This is only recorded in this wireless transmitter. So let's see where now. Okay, still here. As we said, I'll make it, this is manual scaling. I'll make it start from 100 to see. Now completed. Also here, I'll make it 10, for example. So you can see this one. Now, some people, they asked me use different objective function. I told you this is not the problem of objective function, the problem of optimization. But I will, for example, I designed another open project. I designed another one open here. For example, this is the rastrigen function. I will copy this one to my project here. Okay. So this is called rastrigen function. If you want to make it 0, for example, here this is 0, so no problem, make it 0. And this is the objective function. So instead of sending this objective function, I will remove it from this point to avoid any conflict, and I will send only this objective function, the same name. So it will, and the same X variable that is received here. And this, for example, I use the same dimension, which is 10. This is the dimension. I'll add, for example, here annotation, and this is dimension 10. If you change the dimension, you can change here for this also function. So you can see this is the rest region function. I will save this now project, and again I will go to the optimal design and I will run the set. For the restoration, okay, see this is higher. It started from higher because the restoration is different. So you can make this one, for example, 300. Let's see. Okay, so it started from the objective function started from the higher. And here I will make it, for example, 20. See this one now, it is optimizing, and you can see the best value is saved. And here the variables are changing. For the restriction function, you can see that x between minus 5.12 to 5.12. But here in Grey Wolf, till now I didn't change this one, still from 0 to 5. So I'm going to change it. I will make it now 5.12 till 5.12 as, okay. So I don't want to wait. I will stop that one. And again, I will save this one. Again, I will run the set. And now it is different. And also here, maybe I can make it from -5 to see if there is variables in minus. See, this is first one, second one. You can see second one is minus. Some are minus, some are. And it is saving the best solution, you can see. So this is now optimal design. This method now is for optimal design, offline optimization, optimal design. So this is your project or my project here. What I designed now I'm designing the optimal variables for this, for example, project using Grey Wolf. And there is wireless transmitter between this project and the other project. And this is what I did in my PhD optimization to optimize the whole project. And the second video, I will explain how to apply Grey Wolf Optimizer for power system and for controllers of grid connected converters, and how to design the optimal controllers. Then after designing the optimal controllers, if there is a changing of the grid operating conditions, then how to tune these controllers by doing online optimization. So I hope that you keep watching my series videos, and as I promised, at the end of this series I will share with you the whole project, the PSCAD files that now you know that how, for example, to copy, as I told you previously, how to copy, for example, Grey Wolf to your project by using this one, as we said, copy with dependents. So I hope this is useful till now, and I hope that you keep keep following me and following my videos. Thank you.